Hey guys, Mr. Bowman here. Today's learning objective is in orange and we are learning to calculate x in an inverse normal distribution question. So the first thing I want to go over is what makes a question an inverse normal distribution question. So a normal distribution graph looks like this, and in our earlier video we told to enter in 50 as our mean. Our standard deviation was 10, and let's say we had 55, and let's say we calculated this to be 0.2. An inverse question is a question where you're given the probability and you've been asked to work backwards to find either the standard deviation, the x value, or the mean. In this video, we're focusing on calculating the x value. So let's get into an example. So there's my normal distribution curve, a poorly drawn one. Let's say we were told our mean was 100 and our standard deviation was 7.5. We can use inverse probability skills to calculate for which value would the top 10% of individuals lie. So in our case, we've been given a probability and we're working backwards to find x. If we're using the inverse normal distribution function on your calculator, if you need to know how to use that, have a look in the description to this video. There'll be another link to how to use the actual calculator. Our calculator requires us to input the tail of the data, the area of the data, the standard deviation, and the mean. And all of this is information that we can see on our graph. So the first thing we've been asked to enter in is the tail, and the tail normally means is it the left or the right? And in our case, we can clearly see we're looking at the right tail of our data. The area, that relates to the probability of the area you're looking for. So that's 0.1 because the top 10%, the area we're interested in, that had a probability of 0.1. The standard deviation, we were told that was 7.5, and our mean in the middle, 100. If you enter that all in your graphics calculator, that will tell you the inverse value of x was equal to 109.6. And let's just say that was in meters or whatever it was, and we've rounded that to 1 dp. So using the probability, we've been able to work backwards to find out the x value of that. And so that means the top 10% of people will have a value of 109.6 meters or higher. Another example, carrying on from that, there's our normal distribution curve. Our mean is 100 still, and our standard deviation is 7.5. So instead of looking at a tail of our graph, how would it work if we were looking at the middle of our data? So as an example, let's say we've been asked to find out the middle 50% of values and what the corresponding x values would be for that middle 50%. In other words, for what range of values would the middle 50% lie between? So following our calculator method, our tail, we don't really have a tail, but we're dealing with the center of the data. Our area, that's 0.5 because we're looking at the middle 50%. Our standard deviation, that's still 7.5. And our mean, that is unchanged at 100. If you put that in your graphics calculator, it is going to tell you x1 was equal to 0.9 meters, and I've rounded that to 1 dp. And it's also going to tell us an x2 number, which is what makes it different from a left or right tail question, because we're trying to find out two x values. So x2 of 105.1 meters, and that was also rounded to 1 dp. So that means the middle 50% of this data will lie between 94.9 and 105.1. Thanks for listening to this video. Hopefully you found it useful. And just a reminder, if you need instructions on how to use your graphics calculator for inverse questions, please have a look at the video in the description below. Thanks very much.